Okay, so we have in previous class we have seen the steps for design of your licensing system. Very good morning to all of you. Myself, Professor Dr. Mirza from Maulana Mukhtar Ahmad Technical Campus. So today we will solve one example on built-up compression member, and then our unit number 2 will finish after these examples. So design a built-up. Write down this example. You will sit with the pen and paper so that you can understand what to write down with me. Okay. So this example we will solve. I will. This is our lecture number. I think so. 28 DSS. Today is 16/9/2002. So happy Engineers Day to all of you. Yesterday the Engineers Day was there, and engineers make this word and build this word, know this word, connect this word, all of the inventions from the engineers. Okay, you are also become an engineer after 2 years, and you have also do something to your society that will be beneficial for the society and nation. So we will solve today this example. Design a built-up column. Write down the example. Open your camera. Write down this example on your notebook. Design a built-up column 10-meter long. Design a built-up column 10-meter long to carry a factored axial load of to carry a factored axial load of 1080 kilonewton. 1080 kilonewton. The factored axial load uh, of 10-meter column, the unsupported deck is given 10 meter, and the factored axial load is given uh, 1080 is given 1080 kilometer. Okay, so we are writing the data, given data, given data. Okay. Write down this question in your notebook. The column is restrained in position but not in direction. The restrained in position, the column is restrained in position. The column is restrained in position but not in direction at both ends. Column is restrained in position but not in direction at both ends. Provides single lacing system. Provides single lacing system with bolted connection. Assume steel of grade Fe 410 and grade of ball 4.6. The steel is Fe 410, grade of ball is given 4.6. 4.6 generally is a black ball, and black balls are fully threaded. And black balls or common balls or rough balls, they are fully threaded. Design the column with two channels placed back to back. to design the column such that the column you have to design the column such that the two channels they are placed back to back. These are the given, and we have to design nesting system. It's already asking column design lesson system. Okay, this we have to design with two channel they are back to back. The two channels they are back to back. So this one is our okay. Now we will solve this example uh, because L is given, PU is given, and Fe 0 is given. So step one for design of the built-up column is similar to the design of column. First, we have to assume. First, we have to assume FCD. First, we are doing assume the FCD because here we don't know uh, the section. Just we know that two channel section here to be provide back to back. Only this we know, but the size of section, this type of section we know, but size of section we don't know. So definitely for column we need an effective area to select a section. For that, the step number one is you have to assume the FCD. Assume FCD 150 MPa or 150 Newton per mm square. So in step number one, I told you earlier that you have to assume FCD in between 125 to 175 MPa. Okay, that is Newton per mm square. So step number two, you can, because you know the load, effective load, factored load, you know the factored load. Step number two, uh, you have to find out the effective area required. Effective area required. The area required will be factored load upon assumed FCD. The factored load is 1080 kilonewton into 10 raised to 3 Newton, and FCD you have assumed 150 Newton per mm square. The area required will be 7,200 mm square. 7,200 mm square. 7,200 mm. This is the area required. Now, based on this area, we have to select the section. We have to select the section based on this area required. If you select the section, the selection of section is where we have to choose two channel section. So if I will divide the area for single channel will be, there is required area. I will write down required area for single channel will be divided by 2. It is 3,600 mm square. Okay. Now we have to select the channel such that this area should be more than 3,600 mm square. So for that we have to go for our steel table, and steel table is nothing but your IS 808. In that case, You can find out the steel table. So you have to select the channel section. When the I section, you will go for the channel section. Here is the channel section. This is also I section. Oh, here is a channel section. We will choose a channel section, and this properties is given. CY, EY, P, the width of land, capital D is depth of the section, and B minus T by 2 is for the connections. T is the thickness of small t is the thickness of web. And capital T is thickness of plan. Thickness of plan. Okay? So this is already given. So we have to select the section with area more than 3600 mm. So if you come here, I will select the section. You can see here the area is in centimeter square area 3900 mm square, and ISMC 250. This is ISMC 250. Okay. So ISMC 250. If I will check the area is larger than this, the area is 3939 centimeter square, means 3900 mm square. Okay. So it is nearly, or it is greater than that area. Now, if you go for the star section, we will not select. It is for the heavier section in which size intended for use in wagon industry are to obtain from same set of rolls and corresponding flat section in the size of group. Now again you see the ISMC 300, the area will be 4630 mm square, which are much larger than this. So which one we will select? We will select this one. This area is also large. This area is also large. Okay. So it depends on you. For first trial, you have to select the section. So area, sectional area is given 4630. Okay. And this area 39,000. So anyone you can select for your design. Okay. So we will go for ISMC 300. This one ISMC 300. The area will be 46.3 centimeters square. So I will write down. We are going for the higher side. Select section. Select ISMC 300, select ISMC 300, about 36.3 kg per meter, about 36.3 kg per meter, having area is equal to 4630 mm square, 46.3 centimeter square. We convert it in mm, 4630 mm square is the area. Now we write the properties of the section. Properties of ISMC. That is sectional properties of ISMC 300. So you can write down D, capital D. is 300 mm. Width of flange BF is given capital B. Uh, 90 mm. BF is 90 mm. Okay. Now TW is equal to and TF is equal to TW and TF. Capital small t is TW. Capital D is TF. 7.8, 13.6. 7.8 is TW and 13.6 is TF. These properties are given. Okay. And area already you have written above. Area is 4630 mm square. Okay. These are the given. Now we know that PD is equal to AE into FCD. So we have to find out FCD. You have to take AE as AG when section is at least in semi compact limit. तो यहाँ पर हम लोग क्या करना पड़ेगा वापस से यू हैव टू डू फॉर ये मालूम करने के लिए नाउ यू हैव टू टिप नंबर 3 the effective length because both side hinge condition is there. So LE is equal to 1 times L yani 10 meter. Okay, because translation is rotation is not restrained. Okay, so I will write LE is equal to L. And step number 4, we have to do the section classification. Why we are going for the section classification? We are going for the section classification to know that section is plastic, class 1 plastic, class 2 compact, and class 3 semi-compact, and class 4 is slender. So generally we are not going for design of slender section. Okay. If section is in these two limit, that is plastic or compact limit, section is plastic or compact limit, class 1 or class 2 लिमिट में अगर आपका सेक्शन है तो it is said to be that your effective area is equal to the gross area. That's why we need to classify the section. And section classification we are doing from the table number 2 of IS code, that is page number 18. So you can see on the page number 18, this is page number 18. So you have to do the section classification for the channel section. So if you going for the compression flange of your rolled steel section, the TF ratio should be less than 9.4 E अगर है तो it will be class 1 plastic. Otherwise, if it is between 9.4 E to 10.5 E, it is class 2 compact. And if the value is in between 10.5 E to 15.7 E, then the class is semi-compact. And the value of B by TF ratio is greater than 15.7 epsilon. It means that your flange is slender. Okay. So now for channel section, you know, channel section, this is the B, the width of flange. Okay. And T is the thickness of flange, TF. So we know the B and TF will put here. section classification. So B by TF value. B we know that width of flange is 90 mm and thickness of flange is given 13.6 mm. So it is coming 6.617. This value, if you check from table number 2, from table number 2, page number 18 of IS 800, this value is less than 9.4 epsilon, and this epsilon is nothing but under root of 250 upon Fy. Our Fy is 250, so 250 upon 250 under root of 1 is 1. So our flange is less than 9.4 E. If you come to table, so rolled in steel section or steel element of compression flange, this first row is V by TF ratio is less than 9.4 E. It means that our class is plastic. Our class is, here we can write on class 1, class 1, class. Now this is only flange part. Now D by TW ratio is the web portion. The web portion is 300 mm. So D is nothing but minus D capital D minus 2 times TF minus 2 times R1. So this value you can directly get from the IS code also. So that from R1 is 13 and thickness is 13.6. You can find out the small d value. So D is 300 minus 2 times 13.6 minus 2 times 13. Okay. So if you do that, so it will come 24.7 divided by the TW, thickness of web is 7.6 mm. Where is the thickness of flange? 7.8 mm. I will write down 7.8 mm. Thickness of web. So it is coming something like a solid with calculator. Calculator is allowed, IS 2007 is allowed, steel table is allowed in theory classes. So 40.7 divided by 7.8 is coming around 30.85. Now we have to again check it from table number 2 of IS code. So when channel view of the channel section D by 2 to W ratio is less than 42E, it means that this class is semi-compact or plastic. Okay. So only one criteria is there for the channel section. So this is less than 42 epsilon. It means that the web of channel section is also plastic. Okay. So class 1, plastic, if I will write. And because the flange and web both are plastic, it means that the section is plastic. If section is in class 1 plastic, it means that your AE is equal to AG. Means that your AE is equal to AG. So this part is over. Now you have to find out. The slenderness ratio. Step number 5. To find out FCD. Calculate FCD. So FCD you have to find out from the table 9C because because channel section, channel section, channel section is is coming under buckling class C, buckling class C as per table table 10 of table 10 of IS 800 2007 on page number 44. We go for IS code IS 800 2007 page number 44. You can see this buckling classification of the section is visible to you, I think so. Is visible to you, I think so. So you see the buckling classification of section for channel, angle, T, solid, square or round bar, any type, any axis, the buckling classification is C class. That's why we have to use the table 9C to find out the FCD. So table 9C design compression stress FCD for column buckling class C. Now how you can find out the FCD? So you find out the FCD from table number 9C for channel section is under the buckling class C. You know you have to know the slenderness ratio because if you see the table KL by R, KL is the LE, R is the radius of gyration. So lambda is the KL LE upon R minimum. So you have to find out lambda is equal to KL by R. Okay? So we are considering here R minimum, this R is equal to RZZ because we have to put the section H1 distant that RZZ is equal to RYY. That's why RZZ we will take here. So the value of RZZ you can take from the steel table. You can see here this RXX is nothing but RZZ. If I will proceed this row, so RZZ is 11.8 centimeter, yani 118 mm. So RZZ is 118 mm. Okay, and LE is equal to K times L, that is 10 meter and 10,000 mm. So if we find out the lambda will be 10,000 divided by 118 is coming 10,000 divided by 118 is coming 84.7. This is slenderness ratio. But in case of lashing system, we have seen that we have to increase by 5% with lambda E. The lambda, if you increase the 5% to 1.05 times 84.7, so lambda E will be 88.9. So this is lambda. So FCD is given in table. The FCD is given in table for FY 250. In case our FY is 250, lambda you know, FY you know, you can easily find out the FCD from the table. So 250 और FCD हमारा कितना है 88 point something 89. But here is the value for 89 is not given, so 80 or 90 is given. Value for 80 and 90 we will take. The value for 80 FCD, value for lambda is given for lambda 80, the FCD is 136, and for 88.9 it is not given. Find out. For 90 it is given 121. The FCD for lambda is equal to 88.9 can be calculated by interpolation method. By interpolation method. Okay. So if I write FCD, this FCD we have find out FCD for lambda 88.9 is equal to 136 minus, okay, 88.9 minus 80 divided by 90 minus 80 into 136 minus 121 is extreme value. So FCD will be it will be 136 minus, this is 10, this 5 minus 2 is 1.9, 8.9. So you get the value. So solving is 28, right, 8.9 into 15 divided by 10. Okay, so 136 minus 13.35 is coming 122.65. Now we know the FCD. Now we know the FCD. The FCD is equal to 122.6. So we can find out the PD for single section. PD for single section is AE into FCD. But we are using double section. We have to multiply 2. So AE is 4630 into FCD is 122.65 into 2, because 2 channel section back to back we are using. So strength of that into 122.6 into 464 into 2. It is coming 11T5.74 mm Newton for Newton, sorry, only Newton, not per hour, because already we have multiplied area. So this into 10⁻³ Newton. If I write the PD is 1135.74 kilonewton, is greater than 1080 kilonewton. That is PD. Okay? So selected section, you can say that selected section is okay. Selected section 2 ISMC 300 about 36 kg per meter is okay. We can proceed. अब ये हमारा यहाँ तक क्या हुआ है कि हमारा जो 2 चैनल सेक्शन है वो ओके है, हम उसको ले सकते हैं. ओके, वो चैनल सेक्शन हमारा ओके है, हम उसको ले सकते हैं। अब यहाँ से आपका डिजाइन शुरू होगा। नाउ फ्रॉम हियर up to this up to this up to this only main member design completed. Main member design completed. Now from here, from here, you have to design. जगह भी लिखते हैं, design lacing bars, and in problem it is asked as single lacing system. Single lacing. So we have to design single lacing system now from on. Now it is also given in example. It is also given in example. Also given. That two sections are connected back to back. So two ISMC we have to connect back to back. तो अगर मैं यहाँ पर एक फिगर बनाता हूँ, draw this figure. You also draw this figure. It is very important. This is the channel section. The channel section. Okay. This channel section we are connecting back to back. This channel section we are connecting back to back. Okay. Now if I will draw the axis, draw the axis. So this axis is axis for the whole body. This is Z axis. It is also called as major axis. And y axis, that is minor axis, will be somewhere here. Y axis, or you can say the minor axis, will be somewhere here. Somewhere here. Okay, and y minor axis of this body is somewhere here. Okay, that's why we talk. This for this section will be here, and the axis for this section will be here. And this is called as, this distance is nothing but, it is called as CYY. It is called as CYY. Okay. And if I will say this is the distance between the two channel section, and if I denote this S, the distance between from the center of the minor axis, if I will write down, So it will be the S by 2, and here it is S by 2. Okay. So this is the our y axis. This is the main road section y axis. Okay. So ZZ axis, the axis is coincide. So if I will write the IZZ, so IZZ is equal to 2 times IGZZ. Okay. So 2 times, if I write down IGZZ, so 2 times of that I IXX or IZZ given in this example. So where it is given IXX, it is 6420. So that is 2 times 6420. It depends to 4 mm raised to 4. Okay, it is given in centimeter raised to 4. It is given in centimeter mm raised to 4. Centimeter raised to 4 it is given. So you convert mm raised to 4 by multiplying this. And Iyy about its own axis it is given 313 is equal to 4 mm raised to 4. Okay, but here this is only about the this. So this is IGYY. Now we have to find out IYY of two section apart. Two section apart can be find out. Can be find out. Find out by parallel axis theorem. Parallel axis theorem. So what is the parallel axis theorem? So Iyy is equal to because two section is there 2 into IGYY plus area into H square. So area section you know, and what is the H? H is nothing but the distance of centroid of the whole body to distance of the centroid of the section. That is H. So if you write here H you can write here. This is the H value. You see the H here. H is equal to S by 2 plus CYY. S by 2 plus CYY. And this S we have to find out. This S. If I will write it, so it will be 2 into IGYY plus A area into in bracket S by 2 into CYY square. You can write like that. Now we know that radius of gyration R is equal to under root upon I upon A. Okay. If you have to put RYY is equal to RZZ, it means that we have to equate IZZ is equal to IYY. If I will write here 2 times IZZ कितना है हमारा? We have written here 2 times 6420 into 10 raised to 4 is equal to 2 times in bracket 313 into 10 raised to 4 plus area area of the section. Where is that area of the section? Area of the section is 6430. I will write 6430 4630 into h square. Okay. Now this 2 and this 2 will be cancelled. So what it will be? 4630 into h square is equal to 6420 minus 313 into 10 raised to 4. Okay? So 6430 minus 313 is coming. So h square is equal to 6117 into 10 raised to 4 divided by 4630. So h square is equal to 10 raised to 4 611 6117 into 10 raised to 4 divided by 4630. So this h square will be 12.
हेलो
हाँ हेलो
सर, वो 66107 है। 07।
6420 minus 313.
हाँ सर, वो 6107 इंटू
हाँ
10 रेस
सिक्स
टू
वन
4।
ओके ओके 6107 into 10 raised to 4 into 10 raised to 4 divided by 4630 is coming 13190. H is equal to under root of 13190. It is coming 114.85. 114.85 mm, and H, H is nothing but is equal to S by 2 plus CYY is equal to 114.85. Now you can find out the CYY from steel table. The CYY here it is given in column number 11 is 2.23.5 mm. It is given. It is not in it is in centimeter. So it is in centimeter. So 23.5 mm. So CYY is given. So I will write down CYY from steel table is 23.5 mm. 2.35 2.375 centimeter, 23.5 mm. So S by 2 is equal to 114.85 minus 23.66 or 7 mm. I will write down. So S is equal to 2 times of minus 23.66 is 2 times of 91.24. So answer is equal to is coming 182.49 mm. Okay. So now we have find out the spacing of this uh, channel section, how much it will be. So it is coming around 182.49. So we will do the round figure, we will take S is equal to 184 mm. take the S is equal to 184 MB. So we will stop here and we will solve this example. In coming class, tomorrow inshallah we will complete. So up till now, you can understand this is the how to find out your how to check the section strength. That is, you calculate the PD, and PD of selected section is same in our case. Now we have find out the spacing के channel section को कितनी दूर हमको रखना है, that is yes. Okay. So this is for today's. We will stop here and continue tomorrow this example and we will finish. If you have any doubt, you may ask with me, or otherwise we will stop here. कोई डाउट है आपको तो आप पूछ सकते हैं, अदरवाइज वी विल स्टॉप. So it is not too tough for design of built-up section, but you have to follow the steps properly. Then first we have find out the section strength, and then we have to design for the lashing or backing system. In both cases, okay. So we will stop here. Don't have any time. We have another class.